During a panel at the Lucca Comics Festival in Italy, when Hirohiko Araki was asked about Dio's stand, the world, why it has oxygen tanks on its back, he responded by saying they were used to provide the entire world with oxygen during the stopped time. So of course we're gonna do a stand science about that. Just who the hell do you think I am? Even with this explanation, it opens up a new can of worms. Like, how could Dio breathe under the sea if his stand didn't manifest until he met Enyaba? Are vampires really that immortal? Because you know how immortal is in JoJo's. Do vampires need to breathe? If you need to have oxygen tanks, then why doesn't Star Platinum have them? Oh, I know he's got big lungs. Is that why he can only stop time for 2 seconds and not the full 5 to 9 seconds? How does Silver Bullet move in the stop time? Does Zawaldo just pick up the horse and carry it? That kind of disproves the idea that only Dio gets to breathe in the stopped time. I mean, this only solidifies my previous theory that stopping time is actually moving really fast, because Maid in Heaven is even able to move freely in the stopped time, concluding that not all motion has ceased. But none of that actually matters, because if you just throw in a little fan service into your most recent chapter, everyone's gonna say you never forgot anything. God, I love JoJo. So, let's figure out, could this actually work? No. Turns out, funneling the entire atmosphere into 2 oxygen tanks doesn't really work. Big surprise. There's currently no existing material that could possibly do that. And I'm going to prove it, first by determining the pressure of the tanks, and then determining the stress on those cylinders. Before we get into the meat and potatoes of the math though, let's talk about diving suits, since lo and behold, Dio's stand is a holy diver. John Lethbridge designed the first sealed diving suit in the early 1700s, and since then, there's been a variety of diving gear and wetsuits throughout the centuries. Diving suits range from dive skins, wetsuits, and dry suits, all based on the temperature and depth of water that they'll be used in. So today, we're going to be looking specifically at diving gear that can be used at regular atmospheric pressures, temperatures, etc. A diver that fights on horseback during the final stage of the Steel Ball Run race, the Manhattan Rhapsody. To start off, the world has 2 oxygen tanks on its back. The size of the tanks, based on standard oxygen tanks used today, and the reference size of the body, put the cylinders at 26 inches or 66.4 centimeters. These tanks hold an approximate volume of 18 liters each, maximum. Thankfully, the volume of our container is not going to change because it's constant, which really helps our calculations. To figure out the pressure of the oxygen tanks, if the entire Earth's atmosphere was shoved into them, we're gonna need some help from my mortal enemy. As a physicist, it pains me to do so, but I need chemistry.
And that slow movement, that's deceiving. With one lash of that tail, they can have really great bursts of speed. He's coming in again. And
if there's one thing you should take away from high school chemistry, it's this little equation right here. PV equals nRT, PivNert. This is the ideal gas law, and it tells us everything we need to know about this problem. The ideal gas law is used to examine the relationship between problems and scenarios that have variable pressure, temperature, or volume. P is pressure, V is volume, N is the number of moles of gas, R is a constant, and T is temperature. The key takeaway you need to know from this equation is that there are no attractive forces between the particles inside the container, and that both pressure and volume are directly proportional to a change in temperature, which means if the pressure and volume increase, temperature is going to increase, and vice versa. Well, we know our volume, which is 18 liters per oxygen tank, which gives us 36 liters total to work with. But since the tanks are separate, we can assume they're both taking in 50-50% of the atmosphere each. So when we do the calculations for cylindrical stress, I'm going to have the amount of atmosphere that's going into the equation, which would be our number of moles. But what is number of moles N? Moles, no, not those kinds of moles, basically measure something that doesn't have units like grams or milliliters. They represent the number of atoms in a system, 3 molecules, which is otherwise known as Avogadro's number. This single number basically standardized the way we can count quantities of any substance on Earth, big or small. The reason we use moles instead of grams, since the atmosphere is mostly nitrogen, we're going to use what's called the molecular weight, or the number of grams per mole, to determine our N. But since nitrogen is diatomic in nature, we'll use something that I was taught day 1 of my high school physics class that never went away. Let's get anal in dimensional analysis. Dimensional analysis is basically just keeping track of your units when you're converting values. A basic example is 1 inch is the same as 2.54 centimeters. I like to visualize it as fractions moving along the page. All units must cancel out in the end until you're left with what you want. So if we take the mass of our atmosphere in grams and shove it through some dimensional analysis, bing, bang, boom, you're gonna get what you're looking for, which is 1.736 times 10 to the energy. Absolute zero means 0 Kelvin, which is basically when all particles cease to move, i.e. a stopped time. But we can never actually reach that. And this is even more evidence for my previous theory about the world. So since we're going to be using about room temperature, which is 22 degrees Celsius, the freezing point of water is 0 degrees Celsius, which equates to 273 Kelvin. Just add 22 to 273 and you get 295 Kelvin. Easy enough. Finally, we have the ideal gas constant, kilopascals, because pascals are a unit of internal pressure and ultimate tensile strength, which kilopascals over Kelvin mole. All this constant is doing is going to cancel out the units we don't care about. So if we move the equation around a little bit, we can get P is equal to nRT. Cancel out those units and we'll get 1.18286 times 10 to the 22 kilopascals. And that is ridiculous. All right, let's put it into perspective, right? That's pushing the inner walls of the cylinder is that gargantuan number. This stresses both me and the tank out. So let's talk about stress.
Thank you.
Stress is a classic engineering concern when designing materials to hold other materials. With our 2 cylinders, we have cylindrical pressure vessels. These vessels have in all 4 directions. Each side of that box is going to have some amount of stress on it. And difference is equal to pressure times area. Moving this around, we get sigma is equal to P. We need to account not only for longitudinal stress, but also hoop stress at the ends of the cylinders. And then using Newton's first law again, this is 2 times stress times thickness times dx, which is equal to PR over T. Most diving oxygen tanks have a thickness around 1/4 of an inch, or 0.00635 meters, and a radius that can be estimated based off size comparisons of the 0.66 meter length from the manga to be around 0.055 meters. That means our longitudinal stress, or normal stress, would be 5.1226 times 10 to the 22nd kilopascals, and the hoop stress would be 1 material on Earth that can handle that much stress. I can't handle that much stress. That's more stress than I have when I'm at school. This whole thing, it's stupid. This is the longest stand science because Araki literally pulled this answer out of his ass on the spot. Never before have I seen anyone fly by the seat of their pants like Araki does, but that's what makes JoJo special to me and why I decide to spend long nights doing these stupid science problems. But hey, really get me motivated in working my real engineering jobs. Let me know what standability you'd like to see next. I also might be tackling things outside stands, particularly like rock human anatomy or other things from part 8, since there's lore elements and a lot of scientific influence that's really untouched at the moment. And